This video is on how to create a field book for the Civil 3D project. Now, the first thing that we have is this is a traverse. It goes from the southwest to point 2 to point 3 to point 4 back to the southwest. We have some side shots here. So we've got the southeast, the northeast, and the northwest benchmarks. You should remember this from the basic survey class. I'm going to go over some information on how to read this data just as a quick review. First thing is I'm going to go ahead and set up my highlighter. The first piece of information in the field book is I am sitting on the southwest benchmark. See how it's in the middle of these two pieces of information? I'm backsighting the northwest, I'm turning an angle to the right, and I'm foresighting point 2. So the distance from the southwest to point 2 is 211 feet, 211.38 feet, and the angle that I've turned is 12 degrees 44 minutes. Now, when you're looking at this, we're only looking at horizontal distance and horizontal angles. So when I create the field book, I'm only going to be inserting horizontal distance and horizontal angles. As we get further into the class, I'll show you how to insert vertical distances and vertical angles. Now, when you're creating a field book, you're actually going to be creating it with the Notepad program. And I'll show that to you in a bit. So let me go ahead and clear this off. Now, the second one here says I am sitting at station 2. I backsight the southwest. I turn 154 plus or minus degrees, and I foresight the point 3. So here's my distance and here's my angle. Okay, so I go to the next one. Now I'm sitting at point 3. I'm sitting here. I backsight point 2. I turn the angle and I foresight point 4. All right, I've got my horizontal distances and my horizontal angles. Now, in basic survey, we actually did the traverse adjustment, the compass rule for the traverse adjustment. In this one, when we use the Civil 3D, we just need the data that we collected out in the field. We don't have to clean it up. So now I am at station 4. Now, in Civil 3, we call them stations. We don't call them setups or anything like that. So it's going to be STN. So I'm at station 4. I backsight 3. I turn an angle, and I look back to where I started at point 1, which was my southwest benchmark. Okay? Again, I have my data. Now I always have to end where I started. Now I'm sitting at point 1 again. I backsight point 4. I turn the angle to the right, and I look at point 2. So now I don't have a distance because I've already collected it in the first setup. But I do have a closing angle, and that's what it's typically called, is the closing angle, because we're closing the traverse in a loop. All right? Now, the next thing is when we're looking at the data and how it's actually read in a field book, like I said, we're going to use the notebook or the notepad to create this field data. So all the information, for example, here is the only thing that we're going to type in. This information over here is not going to be typed in. So the first line of code says NEZ1. That means I know the northing, the easting, and the Z elevation of this point 1. And notice that that's the northing number, that's the easting, and then my Z elevation, and then a description. So how this is reading is you write, and I'm going to change the color. You're going to write the point number first, then the northing with a space, then the easting, the Z elevation, and the description. This first part right here is telling the computer program how it's reading the information. Now, the next line of code says that I'm looking at the azimuth from point 1. So my azimuth information, this azimuth line right here, is 7 degrees, 6 minutes, and 40 seconds. So from point 1 to point 99, that's the code for the AZ, the angle is 7 degrees, 16 minutes, and 40 seconds. Take a look how it's written. It's 7.1640. So the two digits after the decimal place represent the minutes, and the next 2 digits represent the degree or the seconds. And then I have a description. So the first AZ is actually telling me that's an azimuth line from point 1 to point 99, and then it tells me the direction of the azimuth, 7 degrees, 16 minutes, 40 seconds. And I have to give it a description, and we're just going to call it azimuth. Now, I'm going to clear all this information off. Now I'm looking at this line here. We've already gone through the first line, the second line. Now we're on the third line. The third line is just the station that I'm set up on. Basically, I'm set up, I've got my tripod here at station 1. Notice how it's written, STN1. All these dots and occupy point, none of that gets written in your field book data. So I'm at station 1, and it says I'm back sighting benchmark 99. So benchmark 99 is my azimuth mark. Okay, I'm sitting here, I'm back sighting the azimuth, and the next thing I do in this line is AD. That means it's telling me I'm looking at a horizontal angle, and I'm looking at that horizontal angle toward the direction of 2. So my horizontal angle, my foresight point is point 2, and then it has 12.4400. Notice that is the angle that I turned right here. 12 degrees, 44 minutes, and 0 seconds. So that's why it's 44 with a double 0 after it. That means there's 44 seconds. Notice that the next piece of information is the distance. I'm going to erase this for a second. So I've got this angle and this distance because I'm sitting here, back-sighting, turning that angle, and looking forward to this distance. So this should remind you of how it's written in the field book. Okay? So the next line of code, I'm going to clear this out. The next line of code says, I am sitting at station 2. Now I'm at 2. I backsight 1. So I'm looking back this direction. And the next line says, I am turning a horizontal angle foresighting station 21 or point 21. So that means I'm looking at this angle right here and this distance. So now AD tells me I'm turning a horizontal angle, and I'm looking at station 21. The 299.0600, that is this piece of information right here. That means I'm looking at 299 degrees, 6 minutes, and 0 seconds. Notice how it has 06, and then it has 00. So it's 299 degrees, 6 minutes, and 0 seconds. And the distance is here. Now, the description of the point 21 is the southeast. Okay? Now, the next line of code says, let me get my highlighter on. I'm still at station 2. I'm still here. I'm still backsighting station 1. But in the next one, it says AD3. So I'm now looking toward the traverse point 3. It's saying I'm going 154 degrees, 5 minutes, or 50 minutes and 0 seconds. And then it's telling me I'm going a distance of 94.22 feet. And then it's giving my description. Okay? So now, the next line of code says, now I'm sitting at station 3. That's my occupied point. That's a survey term. I'm occupied at station 3. I'm backsighting station 2. And now I'm turning a horizontal angle to my foresight, this direction here, to point 31. So that's what it's saying. I'm looking to point 31. I'm going 172 degrees, 8 minutes, and 0 seconds. Okay? And the distance is 92.87. And my description is the northeast. You never have a point number that has any letters in it. That won't work. But your description can have letters or numbers. Now, the next one says, again, I'm still at station 3. So this is how it's being read. This is how the computer reads it. I'm still at station 3. I'm looking to the back sight at 2. And the next line says I am turning a horizontal angle and I'm looking to the foresight to 0.4. That's what this means, 80 to 0.4. Now, I turn the angle to the right of 69 degrees, 38 minutes, and 0 seconds. And I'm looking toward a distance toward 0.4, 84.39 feet, and my description is 4. All right, now, so I've collected that data. The next thing I'm going to do is I'm going to go to station 4. So I go to station 4, I back sight 3, and I let me clear that out. It says I'm sitting at station 4, I back sight 3, and I turn the angle to 41. So I'm sitting at station 4, I back sight 3, and I turn this angle all the way to to point 41. It's got 268 degrees, 45 minutes, and 0 seconds, and a distance of 76.81 feet with a description to the northwest. All right. Now, the next one says I'm still at station 4. Let me clear this out. I'm still at station 4. I'm still back sighting 3, and now I'm foresighting back to station 1. So I'm sitting here. I back sight to 3, and I foresight back to my beginning point. And I turn an angle to the right of 112 degrees, 46 minutes, and 0 seconds. And that distance is 256.40 feet. All right. Now, the last says, let me erase that. The last says, now I'm sitting at station 1 again. I'm occupying this point. I back sight station 4. And I have a closing angle that takes me back to 2. So this reads exactly like the field book, okay? But it's written in a in a code that Civil 3D can read. All right. Notice that there's no distance down here. There's no distance and there's no additional description. There's none needed because we've already described that point once before up here. All right, so let me show you what it ends up looking like in the notepad. So notepad says over here, okay, there's my first line of code. It matches this first line. Second line of code, you don't need any type of prompting at the front, nothing like that. The other thing I want you to make sure is you notice is when I saved it out, typically Notepad saves it as a .txt file. You can go ahead and save it as a TXT file, but you're going to have to rename it with a .fbk because that's what Civil 3 is looking for. So if you look line by line, I'm only taking the information up until the dots. The dots are just me explaining what this information and how to write it down. But it has to be in this order because this is the way that I'm traveling. I'm traveling counterclockwise, okay? And I'm taking clockwise angles when I do my turns, all right? Now, that's the end of it for the explanation of what the data looks like. So I'm going to go ahead and get out of that. Now I'm going to show you in the next part of the video, the next video is going to show you how to use the Civil 3D program and the database to upload the information for the Traverse project.